So this is the spent motor from yesterday, 16-inch long, 1.5 ID. Has a clay bulkhead and a clay nozzle in it, but it's a spent motor. That is strapped with its bottom 6 inches overlapping onto an 8-foot bamboo pole. The bamboo pole weighs 32 ounces, starts at about 1 5/8 inch diameter up here at where it meets the motor, tapers to about 1 3/16 inches down at the other end. That balances the center of gravity of that assembly is up from the bottom of 66 inches. Now I've made a 1/3 scale foam board cutout of this with which to determine the center of pressure on this. And that is the center of pressure where this balances is up about 21.5 inches, which is 60, I think it was 20.5 inches. That's 60. The bottom line is on this scale, the center of pressure is behind the center of gravity by 1.5 inches, which means on the real model, the center of pressure is going to be behind the center of gravity by 4.5 inches. That means that this will still fall motor down, I don't know, on some sort of an angle until it hits the ground. So my goal is to move the center of pressure forward until it meets the center of gravity and they're at the same place. That will result in this model falling flat to the ground, ideally, hopefully. So I think in order to move the center of pressure forward, if I cut some off the bottom of the bamboo pole, that will lighten that end a little bit. It will move the center of pressure forward a little bit. It will also move the center of gravity forward a fuzz. But if I cut 6 inches at a time off the bottom of this pole, doing that, moving the center of pressure forward and the center of gravity forward just a little bit less, sooner or later I'll get to the point where that center of pressure and center of gravity are at the same point on this model. So that's what I'm going to attempt to do. Well, doing that, cutting that 6 inches off of the pole, moved the center of gravity forward 2.25 inches, but the center of pressure only forward 1.5 inches. So the center of gravity is actually getting farther ahead of the center of pressure by reducing the pole length. So I actually need a longer pole or a heavier pole. I do have some slightly larger poles that came with this batch, so I will I'll try one of the slightly heavier poles and redo all this and see what the ideal size 8-foot pole is, ideal weight 8-foot pole, to get this center pressure and center gravity at the same point. Actually, I had a little bit of a forehead slap movement. I know per the flat profile cutout of this spent rocket where the center of pressure is. Dave Sleater details how to determine the center of pressure on a rocket like this where you're dealing with only round components. Very simple to make a flat profile cutout in something very light, poster board or foam board, and determine where the center of pressure is simply by where that balances. I know that's up 61.5 inches from the bottom. That's where I want the machine to bounce, the spent rocket to balance. I taped back on. First of all, I applied aluminum foil tape to the length of the bamboo, like the Bang Fai makers do. And then I taped back on the 6 inches I had cut out. And I went over to one of my molehills and I plunged. This was a hollow end to the this section of bamboo. Plunged just a few times into my molehill until I got the whole machine to balance. This is the center of pressure up 61.5 inches on this. And now, with that added weight, like we do in the tail of a model airplane, to get it to balance at the center of gravity, this now balances at the center of pressure, which means this should, ideally, fall flat to the earth. And what I want to do is sort of separate my bamboo poles into the various sizes I got. This is about the medium size or on the smaller size of the bamboo poles I got. And I will make a cutout like this to determine the center of pressure of the falling spent rocket with each of the various size bamboo poles I have. And that way I will know where to balance a spent rocket. I'll keep this spent motor to tape 6 inches onto each of my poles, and then I'll just add some weight with mud or whatever at the bottom of the pole, or if I need to, I can also cut the pole off a little bit to shorten the pole, and I can get the center of gravity and the center of pressure at the same point, which should result in a flat falling rocket like the Bang Fai makers do. So I think I'm ready to make another motor, and hopefully this Saturday I'm going to go get a piece of steel conduit to put this in as a launch pole. These things build up thrust relatively slowly. I want this all the way down in a 8-foot launch pole, so that by the time it actually leaves that launch pole, it's built up some speed and thrust and will still fly straight skyward. And I will launch one of these and put some smoke delay composition in it, like the test motor the other day, and I will see how this falls, whether it falls flat to the earth or not. Film on Saturday or Sunday, hopefully. This spent motor and this particular pole, which was a 2-pound pole, now it's got a little bit of weight in the end of it. That whole spent rocket weighs 49.3 ounces, and I'm using 35 ounces, 600 grams of comp in the motor. So I will recalculate the height to which this model is projected to fly via the Acme simulation software.